right, today on the bench we got this realistic TRC-453, and we are going to unlock the clarifier. So let me first start by just unsoldering this these connections here to the speaker, get it out of our way, and then we'll tilt it up and we'll look at what we're going to have to do. All right, give me a minute. Let me unsolder that, and we'll be right back. All right, so we've got that now unsoldered. We'll get this out of our way. And we're going to tilt this up and first look at the clarifier control here. Now this radio is essentially the same radio, the same board here as a realistic TRC-465 and also a Uniden PC-122XL 122. The difference lies in the faceplates and the controls available to you on each faceplate. And the 122, the 465, and the 453 here are all different. So these PCBs here are laid out a little different. So what we have to do, so if you look right here, now I haven't modded one of these 453s yet. This will be the first one of my 453s. I'm going to unlock the clarifier arm. But I can see by looking at this board, obviously one of these two here is going to be our power input to the clarifier. That'll be available on receive and then gets cut when the radio's in transmit. And this is going to be our output here. But I need to first check to see which one of these here is ground and which one is actually power. So I'm going to power up the radio and we'll do some quick checks and we'll see. So we'll be right back. All right, so we just did a quick check with power on and our meter over there, and let's tilt this back up again. Let me disconnect the power from this. All right, so if we're looking at it again here, this trace here, this side down here is actually our 8 volts coming into the potentiometer. This side up here is ground, and for some reason I just figured that was the case. We got a lot more surface area here. It just looked like that was probably the ground side of the PCB. But yeah, so this side down here is the 8 volts power. So we're going to have to cut this trace here. I really don't want to pull this whole PCB out. So, because it looks like there's probably just a resistor jumping over from one place to another, maybe, powering this or sending power to this potentiometer through this trace. But I'm just going to go ahead and just cut across here and cut that trace and disable that input power, and then we'll just rewire it. So let me go ahead and cut this trace here, and then we'll be right back. Okay, we're back, and I decided to go a different route instead of cutting a trace. Instead of being able to fit my trusty Haku in there, which would have been cool, but that wasn't going to fit. I just used some soldering wick here, and I desoldered that pad right there, and I took just a small dental pick here and went and just pushed that. It's probably just a resistor, I'm sure. Just push that resistor out of that hole, and I have effectively completely disabled the power input to the pot. So now I just need to solder a wire here onto this pot and give it a solid constant 8 volts, and I'll run that off of, I believe it was, let me tilt this down. I'm getting it off this IC here. It's the same as doing it for a Uniden PC-122. I've modded a couple of PC-122s using this 8 volt input here as the power source, and it works great. Also did a TRC-465 that way, so this is all the same board, so there's no reason why not to get our 8 volts from the same place. So I'll go ahead and wire that up real quick, and we'll get our 8 volts constant to the pot, and then we'll move on. So just give me a second here and we'll make that change. All right, so we have our power wire for the potentiometer soldered in right there. I like using solid core hookup wire. This is not stranded, this is solid core. I think it just lasts longer for any number of things. I used to build a lot of guitar effects pedals back in the day, and I've always used solid core hookup wire. So radios, same thing. No difference. I like it. I prefer it. So this is solid core hookup wire here, and we've got, like I said, we've already soldered to the potentiometer, and we're going to flip it over here, and where we're going to hook up is, let me see if I can see this through the camera lens. We're going to hook up right here for our 8 volts, right there. And once we get that done, really all the hard stuff's out of the way, in my opinion. None of this is really all that difficult to do. And if you haven't already figured out, this is a step-by-step tutorial on how to unlock the clarifier on one of these Uniden PC122s, realistic TRC-453s, or realistic TRC-465s. They're all the same radio. So yeah, this is your step-by-step unlock procedure here. The unlock procedure I showed on the PC122 in my last video, I showed you what I did, but I didn't actually walk through it step by step as I was doing it. So I figured this time I'd just go ahead and do that. All right, so let me pause this. Let me get this hooked up here, and then we'll move on. All right, give me a minute. All right, our hookup wire is now soldered in place. Or I should say our 8 volts constant wire is now soldered in place. And we're going to flip this over, and I will show you what needs to be done here on this side of the board. Let's see if I can angle this up here so we could see in. Let me turn that off. Let's see. So what we're looking for down here is D25, which is right here, and then R119. We're going to lift a leg of each one of those. It really doesn't matter which one. And when we do that, we're going to effectively disable this transmit offset pot here. So get those two lifted out of the circuit, and then we're pretty much home free other than just aligning it. So let's go ahead and get that done, and we'll be back. Now we're back momentarily. I just wanted to show you a trick that I do when I'm, say, replacing a component on a radio here. If I'm recapping the entire radio, whatever the case is, you know, sometimes looking from the top, looking at the bottom is confusing to me to find the leg of the component I'm trying to find. So typically what I'll do is I'll use a flashlight and I'll shine it underneath the board, and then I can more easily spot the leg of the component I'm trying to reach. So if you look here, if I can do this with one hand, I know that I am on the right component because I can see the light shining through the hole I just desoldered, and that's my D25 right there. That is my, I think that's the anode side of D25 that I just desoldered. So I'm going to go ahead and pull that leg out, and we'll get the R119 out in the same fashion, and then we'll power it up and we'll start our alignment. So we'll be back here in a minute. All right, I just want to show one more thing here. Now that D25 and R119 are lifted out of circuit here. Come on, camera, focus for me. Let's see if I can, yeah. So what I do here is I don't completely remove the component. So here's the leg of D25, and here's the leg of R119. I leave them in place. That way, if myself or if somebody I might give this radio to, or maybe I sell it to, which I highly ever doubt, but if I gave it to somebody and they decided they wanted to relock the clarifier, they could more easily do it just by putting those components back in place. So yeah, and there's nothing wrong with leaving them like that. They're not going to affect anything. They're not going to become mini antennas or any of that other crap. They're fine just to leave in place. So I just wanted to show that. Just a way of keeping track of what was in there for me or somebody else in the future. Okay, so let's get this thing powered up, and we'll look at how I align it, which is not, I mean, well, I've said this in the past. When you unlock a clarifier, you throw your PLL alignment from the service manual right out of the window. It's not going to be the same. Typically, when you see online, when you search online for an unlock procedure, what they'll do is they'll reference that you're going to, after the fact, align your transmit offset pots, which are these three on this side here. And this is just generally speaking for any CB radio that you've unlocked the clarifier on. They'll generally say, hey, just realign the transmit offset pots. But sometimes if you do that, and let's say that, so here's the lower sideband transmit offset pot, upper sideband transmit offset pot, and the AM transmit offset pot. Let's say that you make your adjustment and you find that you've got to adjust this almost all the way to the very top here, to the very end of your range. what you'll find is when you listen to lower sideband, then it's going to sound a little funky. I mean, obviously sideband already sounds kind of funky, but it'll sound very high pitched. Even though you're on frequency, it'll change the audio pitch drastically, and it sounds like you're listening through a tin can, and it's horrible. So what you can do, and what you never see anybody say, now here on this side is a lower sideband receive offset pot. You can use these two adjustments in conjunction with each other to set your overall output, transmit and receive output frequency, right? And you never see anybody mention that. I really don't understand why. So what I'll typically do is, and I can't tell from looking through the camera right now where this transmit offset pot for lower sideband is sitting in its adjustment, but if it ends up looking like it's going to come up really high up and be towards the end of its adjustment, I'll just go ahead and screw it back down part of the way, and then I'll adjust the receive offset pot and kind of use the two in conjunction with each other to set my overall frequency, instead of actually looking for the particular offset frequency in the PLL alignment of the service manual. I look at the output frequency on a freak counter. So I'll key the radio, and then I'll make my adjustment across both the transmit offset and the receive offset pots to set my output frequency when I transmit, which, you know, now that you've unlocked the clarifier, will also be your receive frequency. So these two will be used in conjunction when I make my adjustment. These two will be used in conjunction with each other, the upper sideband receive and transmit offset pots, and then the same thing for AM. And it'll sound great on sideband at that point when I use them both in conjunction with each other for each mode, and it's nice and stable. So, and you know, this is the same thing as if you were doing anything. It could be a Cobra 148. It could be a Cobra 138 XLR. Like, and those are two prime examples. They have trimmer capacitors for, I believe, like say the 138 XLR has trimmer capacitors for both upper and lower sideband, and you've got almost no adjustment on those trimmer capacitors at all. But you can use the receive offset trimmer capacitors in that board as well to set your overall transmit offset, and it'll keep it from sounding really, in my mind, I consider it tinny, high-pitched audio. You can alleviate that by using both receive and transmit offset. So we're going to do the same thing here, and sometimes you don't have to do that at all. Sometimes you can just barely make an adjustment on one of your transmit offset pots, and everything lines up perfect, and then, you know, it sounds great, and everything is good. But if you run in one of those situations where you start running out of room here, either all the way down for your adjustment or all the way up, you can always set that kind of back in the center and then use the receive offset in conjunction with the transmit offset to set your overall output. So we'll go ahead and fire this thing up, and we'll look and see what we're looking at, and see if we have to actually do that today. We'll find out. All right, we'll be back. All right, so we're hooked back up. We got power hooked up. We have the radio hooked up to our dummy load / power meter over there, and we've got a 1 kilohertz tone generating on our arbitrary waveform generator with 30 millivolt peak to peak output. And we're going to go ahead and key the radio up with our little adapter I wired here, and we're going to see what our output frequency is sitting at. So we're in channel 19 and lower sideband. We should be, what we want, Clarifier is also centered here. So what we want is to see is our lower sideband offset to be 1 kilohertz below the carrier on channel 19 if you were in AM mode. So if in AM mode, channel 19 should be 27.18500 megahertz. So we should see 27.18400 megahertz for lower sideband. That's where we want to be sitting at. So let's see what the radio is doing after unlocking the clarifier. Let's see how bad it is, how much of an adjustment we need to make. So we are keyed up. You see over there, we're pushing probably, I don't know, over 5 watts out. And we're at 27.185. So we've got a long way to adjust. Let me unkey that. And looking down inside these pots right now. Let's see, what are we looking at? Now they're down, the adjustments are down pretty far. So we'll go ahead and just try to adjust it a little bit. This just the transmit offset pot, and we'll see what we can do. So let me go ahead and key that back up, and I'm going to get my screwdriver down there. We're going to get grab the wrong one. All right, we're going to get centered up in there. Let me find it. Jeez, there it is. Okay, let's go ahead and make an adjustment and see how far we can move it. And we're coming down. I don't think we're going to be able to really come down enough, though, with just one pot. Well, we might. I don't know how much we're going to have to adjust it. We'll look after the fact. So we'll come down pretty far already. Maybe so. Let's see. Keep in mind the radio is transmitting right now. I'm looking at the output through that RF sampler, RF sampler I made. So we've come down pretty far. Look, we're at the top of our adjustment point, so we're not going to be able to get enough out of it. So I'm going to go ahead and unkey the radio. I'm going to set that back in because it's going to end up sounding really crappy like that. I'm going to put this back in a fair amount of way there, and I'm going to move my receive offset pot a little bit and see what we can do. Radio's not too warm. All right, I'm keying up, and now I'm in my receive offset pot there for lower sideband, and we're going to make an adjustment. So I see I screwed it back in a little bit. We've gone up. So now I'm moving my, look at that. I moved my receive offset pot just a little bit, and we've lined up almost perfectly. Just barely moved it. Just trying to get it close there. There we go. That's pretty close. That's where we want to be at right there. And if we look at our pots, let me unkey it. So what do we got here? Yeah, so we've got basically our two pots, right? The two right there in the middle. Instead of being, let me see if I lay this down. Instead of this pot being way up here at the top. And another thing, if you get too close to the top on these adjustments, you'll just end up making your frequency totally erratic. It'll just jump all over the place because you're at the end of your adjustment, obviously. So I dropped this one back down a little bit, and then I just barely moved this one a little bit, and we were able to get that frequency exactly where we wanted it to be at. And I'll key up one more time. There we go. Look at that. Very close to where we want. We're within 3 hertz. Well, now, 5 hertz. We can probably adjust that just a little more. Let's see. I'm just going to touch the adjustment or the transmit offset pot. Oh, I'm going the wrong way. Hold on. Oh, just went up too high. That's pretty close there. Oh, missed it again. There we go. That's close enough. That is close enough. It doesn't have to be dead on. The clarifier is unlocked. You're going to be able to track whoever you want. Okay, so now we're going to go ahead and move on to, probably wasn't a good idea to leave that flashlight sitting there. All right, so we're going to move on to our upper sideband, and we'll see what the frequency looks like, the output frequency looks like there. See, again, what I'm doing here is I'm not on a test point here on the board doing what would be considered like a PLL book alignment where I'm looking for the actual offset frequency on a test point. I'm looking at what the output frequency of the radio is. So this is completely different than what a PLL alignment would tell you to do. But this is just how I prefer doing it. To me, it's just easier this way, more reliable. All right, so let's go ahead and fire it up now in upper sideband. And just like lower, our upper sideband should be sitting 1 kilohertz above what the carrier frequency would be on AM, which is 27.18500. So we should be sitting at 27.18600 for our upper sideband frequency on channel 19. So we'll go ahead and key it now, and we'll see where we're at. So we're not as far off. Okay, so let's go ahead and start with our upper sideband transmit offset pot here. If I can find the, where is it? There it is. I finally got into it. Okay. So let's see if we can drop this down a little bit. Moving a lot better than on the lower sideband. Oh yeah, we'll really line this one right up and no problems. We probably won't even have to touch the receive offset pot. Look at that. Yeah, I barely moved it. Very close. Yeah, I'm just going to leave that one alone right there. All right, so we're 1 kilohertz above the carrier. Now what we'll do is we will put her in AM, and we're going to get rid of that 1 kilohertz tone over there. And we're going to we're going to dead key on AM and see how close we are to what our carrier should be, 27.18500 megahertz. And then we'll make an adjustment again there. So we are at 27.185.931. We're pretty high. All right, so let's go ahead and get on our transmit offset pot for AM here. Let me see if I can, there it is, I'm in it. Okay, so let me go ahead and drop that down some. All right, that's moving pretty good. We might not have to adjust the receive pot at all. And this, you know, you're not gonna, won't sound as bad on AM. You got a much wider bandwidth, and it's not affected like sideband is when it comes to sounding tinny. All right, so we're getting real close here. We're almost there. That's pretty dang close. There we go. There we go. And we did not have to move it that much to get there. So, yeah, so the only one we had to use together in conjunction with each other was just lower sideband here in the middle. And we are straight on the money. So let me hook a mic to it, and we'll listen to it on our monitor radio and just see what it sounds like. And then we'll be done. All right, I'll be back here in a minute. Back. I got a mic into it, and I ended up having to go back and readjust upper sideband. So, you know, I said I didn't think that we had to move that much on our upper sideband transmit offset pot to get where we wanted, but it was too much. Upper sideband, like I said, or either sideband, lower or upper, will start sounding tinny in its audio through the mic, outputted through your radio, or on your receive. It'll just sound tinny. So I had to go back and I just twisted this transmit offset pot back down about midway, and then I went to the receive offset pot and I adjusted that one. Got on my 27.186 kilohertz frequency that I wanted to be on, and then it sounds great now. So it was completely functional the way it was, but now it sounds like it should. So we'll just go ahead and listen to it. We're in lower right now. Let's go to lower on this radio. Excuse me. All right, I'm going to key up here and talk on with our mic. Check. 1, 2, 3, 4. Low 1, 2. That is lower sideband. We'll go to upper here. Adjust to the upper. We'll walk this back to upper, and we'll listen to it. Check. 1, 2, 3, 4. See, it sounds exactly the same as lower, and it wasn't like that before. So that's why I went back and adjusted it. Again, like I said, using the transmit offset in conjunction with the receive offset. And that's the best way to do it, I've found. All right, now we'll just listen to it real quick on AM. All right, we're in AM. We'll go to AM on this radio. And here we go. Check. 1, 2, 3, 4. Listen to that. Sounds exactly the same in all three modes. That's awesome. All right, so this thing is done. It's ready to rock and roll. Let me get the covers back on, and hopefully there's some skip you can listen to and hear what it sounds like audio-wise on receive, and we'll be done. We'll be right back.
That's about 16 foot tall. I had a cough coming up there. Yeah, it's just I think it's a halfway vertical fiberglass thing. It's old, it's ugly, and it's just miserable looking for that one.
All right, so you got to hear a little bit there. Not much skip come in right now. Anyway, oh, there you go. A little more. So there's a very weak signals coming in right now. I'm running through a DSP speaker, so I'm able to pull them out of the noise floor. These are very, very weak signals, not even bumping my signal meter here. Oh, we all know that guy. So annoying. But anyway, you got to hear a little bit of skip there. But yeah, she sounds great. And that's it, guys. Not much else to it. I hope that helps somebody out. You really need to have a frequency counter if you're going to do this. You really do. That helps you get things lined back up so you can get your center slot where you need it. But other than that, yeah, I hope somebody can benefit from this. And maybe we'll do a 465, a realistic TRC 465 step-by-step next. They're all basically the same radio, the same board. The only difference is these PCBs here behind the knobs, because the faceplate configurations are different. Who's coming through here? Yeah, I missed him. Somebody was coming through with a stronger signal. Anyway, yeah, these PCBs back here behind the faceplates are different between those three radios. This one actually was the easiest one so far to do. I've done the 465s before. I've done the 122s. This is the first time I've done a 453 actually, and just desoldering that one resistor and pushing it down through the board with a pick was a lot easier than cutting a trace. So that was kind of cool. But yeah, next time I'll do a 465, and that way somebody can see as well, hopefully benefit from it if they got a 465 and not one of these 453s. But anyway, hope you guys enjoyed it. 73s, everybody, and we'll see you next time.